All right, so we already have learned about some of the key relationships between probability distributions, including the joint probability distribution, marginal probabilities, and conditional probabilities. Now we're going to talk about the chain rule of probabilities, which builds on our understanding of conditional probabilities. Okay, so when we learned about conditional probabilities, we learned this formula. So the probability of y, given that x has already happened, we learned is equal to the joint probability of y and x divided by the probability of x, right? So this is a simpler look of that same conditional probability formula that we already learned. So from here, we can derive the chain rule of probabilities pretty straightforwardly. So here is a joint probability expression, right? So the joint probability of y and x. Well, I can change that into this here by multiplying this by the probability of x over the probability of x. I can do that because the probability of x over the probability of x is equal to 1. So I can trivially multiply this by 1, right? And if I can multiply it by 1, then I can multiply it by p of x over p of x. So rearranging that a little bit so that we're seeing this p of x off to the side in the numerator, and the denominator p of x, we're now seeing it underneath the joint probability. Well, this here, this part of the equation, it's the same as here. And we know that that's equal to this conditional probability. So we can replace this here with this. And that's what I've done over here. So this relationship, that the joint probability of y and x is equal to the conditional probability of y given x times x, that is the chain rule of probabilities, because it allows us to chain together multiple conditional probabilities. And that works for longer chains. So for example, we can chain together this probability here where we have a joint probability involving z, y, and x. So we can rewrite that as this chain rule of probabilities where the probability, the joint probability of some state z, some state y, and some state x is equal to the probability of that state z given that y and x has already happened, multiplied by the probability that we get y given that x has happened, again multiplied by the probability that x could happen at all. So I think it follows from here that you could have longer chains. You're not limited to just 3 variables. You can chain together many probabilities this way. Nice, so the chain rule of probabilities gives you another tool in your arsenal for manipulating equations that involve probabilities. Up next, we're going to talk about independent random variables, another tool for your probability arsenal.